Hey guys, today we'll be solving question 8 from the problem 2.3 from the book Mechanics of Materials 6th edition by James M. Gear. Here, the question states that a bar ABC, which we can see in the figure, of length L consists of two parts of equal lengths but different diameters. As we can see in the figure, there are two diameters. Here we can say the diameter as D1 and here as D2. And we have also been given the values of D1 and D2 as 100 and 60 mm respectively. Also, both segments have length L by 2, which is equal to 0.6 meter. So the value of L by 2 is given as 0.6 meter. A longitudinal hole of diameter D is drilled through segment AB, as we can see right here, for one half of its length, distance L by 4, which is equal to 0.3 meter. The bar is made of plastic having modulus of elasticity 4 gigapascal, and the compressive load P is given as 110 kilonewton, which acts at the ends of the bar, which means at the cross-sectional area A and C. If the shortening of the bar, so hence the shortening of the bar is limited to 8 mm, so we have been asked the maximum allowable diameter D max of the hole. So let's look at the solution. Here, these are all the numerical data given to us. Now, in order to find D max, if the shortening is limited to delta A, which we know is limited to 8 mm, here the area of section A and section 2 can be calculated by the following formulas: pi by 4 D1 square and pi by 4 D2 square. Now, to figure out delta, we can refer to the formula P by E and in brackets L by 4 divided by pi by 4 in brackets D1 square minus D max square brackets close plus L by 4 divided by A1 and L by 2 divided by A2, the sum of these three. Now firstly we'll have to set delta and delta A, and we further move for the solution of D max, which can be done by using the equation D1 root under E delta A pi D1 square D2 square minus 2pl D2 square minus 2pl D1 square divided by E delta A pi D1 square D2 square minus p L D2 square minus 2p L D1 square, and finally by substituting the values and simplifying we get the value of D max as 23.9 mm.